I know. So, didn't work earlier, so here we go. Okay, guys, everybody up here. We got a lot to cover today. Okay. So, if you liked what we did on the last quiz, good. It's very similar to what we'll be doing for the next one. If you did not like it, you got to get over that because we'll be doing that. So, I could take the quiz that you took. Hey, guys. I could take the quiz that you did and just convert it to what we're going to do today, Radians, and you could take the whole quiz again. That's just how similar this topic is. So basically, what we're going to do, guys, there's no reason that it's written in stone that a complete revolution for an angle is 360. If you measure it in gradients, that's 400 instead of 360. You could pick 100. There's no reason why that number 360 was chosen. Okay. It's a nice number because every number under 10 except for 1 divides evenly by 360. Which one does not? 7. So every other number is an even divisor of 360. So it's a good number to work with. Okay. So what we're going to do today, and the reason you have these plates in front of you, we're going to talk about another way that things get measured, and that is radians. Radians is very similar to what other word that you know mathematically? Radius, radii. Okay. So what is... If you go back to your geometry, what is the perimeter of a circle?
2 pi r.
Yeah. 2 pi r, okay? The way that says is 2 pi r is the distance around the circle. So how many radius does it take to go around a circle according to that formula?
2.
Not 2, but... No. Okay, here's the radius. How many radius? Look in front of that. How many radius? 2 pi radius is the distance. So whatever your radius is, 2 pi of those. So if the radius of the circle is 2, then about 6.2 times 2 is the perimeter. Okay. So what you're going to need to know, this is why you have that circle in front, or the half of a plate in front of you. What you need to be really grounded when you leave today is that this represents pi radians. Okay. This is where 0 is. And this is pi radians, okay? This represents pi radians. Think of it like instead of a whole pie, you got this was cut in half, but this is your pie. You're on a diet. This is your pie. This is it, okay? This is pi radians. So a complete circle would be how many radians? 2 pi radians, okay? So you got to get grounded in that half of the circle, instead of thinking of it as 180 degrees, and it's 180 degrees, but now we're going to stop calling it 180 degrees. We're going to call it pi radians. And then when we make one full revolution, instead of saying that's 360, we're going to say it's how many radians? 2 pi. The reason we do this is because when numbers start to get bigger, like 360, 720, 1040, it's harder to deal with. It'd be easier to deal with things like 1 pi, 2 pi, 3 pi, 4 pi. Those are easier numbers to deal with. They're smaller numbers. So really, what you want to do is just sort of shift gears. You can convert radians and degrees back and forth, but you want to try to just sort of shift your mindset to talking about radians, which is what we're going to do. So let's take a little break from the recording here and let's do the exercise. And we're just shifting gears. You should be grounded in knowing this is where 0 starts, right? So this is, in radians, that's 0. Which way do I go when I measure positive? Which way do I go to measure positive angles? Counterclockwise. Which way do you think I would go with negative angles? Clockwise. That has not changed. So you want to make sure when you leave today that you can look at this, know that this is 0. What is this one over here? Not 180, it's pi. Okay. So when we leave today, we've got 0 and pi. We're no longer thinking 0 and 180. 0 and pi. Okay. So let's start. Now what you can always know, if this is pi, pi is equal to how many degrees? No, pi is 180. Yes.
So like ours, we step into degrees. So like in ours, for instance, we're at 90 degrees now.
Yeah. It's at pi over 2. It's the boundary line between quadrant 1 and quadrant 2.
Pi over 2.
Right. It's the same angle as pi over 2. So, okay. So guys, okay, pi is 180, okay? So for those of you who divide it up into 6, okay, what happens when I divide 180 by 6? What do I get? 180 divided by 6 is 30, okay? So that means right here in radians, this is pi over 6, okay? Now let's add one more 6 to it. I'm going to count by 1/6. So what's 1/6 plus 1/6? 2/6. Do you think I'm going to write 2/6? What do you think I will write instead of 2/6? Yeah, I'm going to write pi over 3, okay? Now, that's 2/6. If I add 1 to it, how many would I have? Come on, guys. 2/6 plus 1/6 is 3/6, but I'm not going to write 3/6. What am I going to write? Yeah, I'm just going to write pi over 2, okay? I'll come back to that one, okay? So if this is 3/6, if I add 1/6 to it, what do I get? What's after 3/6? 4/6, but I'm not going to write 4/6 over here. What am I going to write? Instead of 4/6, I'm going to write 2/3, okay? After 4/6, what comes after 4/6? 5/6. I'm going to write that one down. There's nothing I can do to simplify that one. Okay, after 5/6 comes how many 6? 6/6, but that's pi, okay? So that's where we are. Now, 6/6 plus 1/6 is 7/6. So this is 7/6 pi. 7/6 plus 1/6 is 8/6. But instead of 8/6, I'm going to write 4/3. Okay. 8/6 plus 1/6 is 9/6. But instead of 9/6, I'm going to write 3/2 pi. Okay. 9/6 plus 1/6 is 10/6. But instead of 10/6, I'm going to write 5/3. Okay, 10/6 plus 1/6 is how many? 11/6. So I'm going to write 11/6 right here. 11/6 plus 1/6 is 12/6. But instead of 12/6, I'm going to write 2 pi. So if pi is where 180 is, when I make one revolution, that's how many pi? That's 2 pi. Okay, so you just need to know that the big grounding is when you start out, you start at 0. When you get over here, that's pi. When you get back around, that's 2 pi. Okay, so that's where we're going to count the revolutions. Now, if we look at 45 degrees, so that's halfway. This 45 degrees is halfway between 0 and pi over 2. Okay, or another way of looking at it, here's 45 degrees, 45 degrees, 45 degrees, 45 degrees. How many of those did I just count? 45, 45, 45, 45. How many of those are there? There are 4 of them. So this is pi over what? Pi over 4. That's 2 pi over 4, but we're going to write it pi over 2. This is what? 3 pi over 4, or 3/4 pi. This is 4/4 pi. So that makes this one down here 5/4 pi. Okay. And then the last one here is 7/4 pi. Okay. Now, what you really don't need to memorize this. This is all going to come into play when we start to draw the angles. You'll see how this comes out. But what you do need to know, the unit circle like we've done it before. Okay, so I've got it drawn here, but I mean the next quiz that you have, this is the first question on that quiz, is to draw the unit circle, but instead of degrees, you have to draw it with radians, okay? So let's go back to how we're going to do that. So if we look at that, here's the unit circle that we drew before. This was on your previous quiz, okay? So the only thing that's different is I just need to label where the radians are. So how many radians is it here? 0. And then I always go to this one. This was the easy next one to do. What is this one? This is pi, okay? Okay. What's halfway between these two numbers? Pi over 2. That's half of that, okay? And here's the easy way to remember this. This is 30 degrees, 45, and 60, okay? What is that first digit? That's 3. What's this number? 4. This is 6. So I'm going to write pi over 3, pi over 4, pi over 6, and I'm done. Okay. The only other one is this one right here. If this is 1 pi, and when I come back around, this is 2 pi, what's the number halfway between 1 and 2? 1.5, 1.5, but we're going to write it as 3/2 pi. Okay. So this is what this is the unit circle we're going to be working with now. So we're not going to be saying the sine of 30 degrees. I'm going to say the sine of pi over 6. So if I were to look at this, the sine of pi over 6, sine corresponds to what number? What the y coordinate? At pi over 6, what's the y coordinate? 1/2. What's the sine of pi over 6? 1/2. Okay. Cosine of pi over 3. Cosine corresponds to what? X. Go to pi over 3. What's the x value? 1/2. Cosine of pi over 3 is 1/2. Okay. Same thing in terms of positive, negative values. That all stays with us. Yes, Chuck. Right. The units are different. So it's basically like, think of it like if we had done the previous lesson in inches and now we moved into metric. It's just we've changed the units. Everything else is the same. So instead of talking about angles measured in degrees, we're going to talk about angles measured in radians. Okay. So let's jump into some of these problems and see how they work. So it's the same process we've been going through. Evaluate the sine of 7/6 pi. Okay. Where it says draw the angle, what do you think the first thing we need to do is? Draw the angle. Okay, so I need to figure out where is 7/6 pi. This is the way you're going to do it. What's this number right here? 0. What is this one? Pi. Okay, so that's the way it's going to be because I'm measuring positive angles. Now, you see this 6 here, all right? That tells me I'm interested in subdividing it into pieces that are what? 1/6, okay? So instead of pi, I'm going to write this as 6/6 pi. Okay, does everyone agree that's the same number? 6/6 pi. Now, do you have a feel for where 7/6 pi would be? Would it be in quadrant 2 or quadrant 3? Quadrant 3, because how far after 6/6 is 7/6? Well, there's a precise answer to that. Not 30. I'm at 6/6. How many 6 do I have to go to get to 7/6? 1/6 more. Okay, so this angle is right here. That's the angle 7/6 pi. But more importantly, this central angle. What is this central angle right here? Not 30 degrees. We've stopped talking about degrees. It's pi over 6. Okay, does everyone see that? If this is 6/6 pi, you got to go pi over 6 more to get to 7/6 pi. Okay? Pardon me? Well, that was just so you could see where the degrees correspond to radians. But there's no degrees here, so you're going to have to use the unit circle and radians to figure all of this out. You'll spend too much time if you have to always think pi over 6 is 30 degrees. I mean, you can do that, but it's better to just switch and say, okay, this is talking about the pi over 6 angle in which quadrant? Quadrant 3. So you go to your unit circle at pi over 6. I'm looking for sine. So sine corresponds to what value? Y. What's the y value at pi over 6? 1/2. The y value at pi over 6 is 1/2. I'm in quadrant 3. Is it positive or negative?
Negative.
It is negative, okay? So can you see, other than the degree part, this is the same problem, okay, that you had on the previous quiz, okay? So all we're doing is we're doing these same exercises in radians now, okay? The unit circle and radians, figuring out these same exercises. So again, I've got the same angle, so there's no mystery here about 7/6 pi. But the way I always do these angles, I start with 0, and then I come over here. This is pi, okay? Because the denominator of this fraction is 6, I'm going to call this 6/6 pi. And then that tells me that 7/6 pi is pretty close to 6/6. And it also tells me that it's further than 6/6, okay? So it tells me that this angle is right here. That's the angle 7/6 pi. How much further after 6, 6 is 7, 6? Yeah, that's just pi over 6. So this is pi over 6 in quadrant what? Okay, what's the definition of tangent? Y over x. So go to pi over 6. What is y over x? It's, yeah, so it's 1/2 divided by square root of 3 over 2. Okay, we don't like to leave it like that. And let's just see, it's tangent. What is tangent in the third quadrant? Positive, okay? So this is 1/2. Instead of dividing by square root of 3 over 2, we can multiply by its reciprocal, which is 2 over square root of 3. This answer is 1 over square root of 3. Okay, we're getting the same numbers for answers that we got before because we're dealing with the same angles. Okay, this one has a little bit of a trick. It's the sine of negative 7/6 pi. What do you think that means? We start at 0, but we go the other direction. So if this is 0, and I'm going in this direction, what is this angle right here? Not pi. Negative. This is negative pi, okay? If I started at 0, that's negative pi. Because this is a 6, instead of calling it negative pi, what am I going to call it? Yeah, I'm going to call it negative 6 over 6 pi. So where would negative 7 over 6 pi end up? Quadrant 2. So negative 7/6 pi is going to be this angle right here. So, but more importantly, what is the angle from there to there? Not 1 pi. Yeah, pi over 6. Because if this is negative 6 over 6, how far is it to negative 7 over 6? That's pi over 6 further. So this is a pi over 6 angle in which quadrant? Quadrant 2. So I'm looking for the sine. What's the definition of sine? Sine is the y value. At pi over 6, what's the y value? In quadrant 2, what's the value of sine? It is positive. So my answer is 1/2. Okay? For me? Yeah. So I mean, guys, do you see the similarities of what we're doing? Yes. Pardon me? So if this is 7/4 pi. So tangent of 3/4 pi. The first thing I have to do is to be able to figure out what? It's just like the other quiz. I've got to do what? I've got to draw what? The angle to find out which quadrant it's in. So in all of these, this is 0. What is this one right here? This is pi. But here, I'm not going to call it 6 over 6. I'm going to call it what? 4 over 4 pi. Okay. Now, 3 over 4 pi, where do you think 3 over 4 pi would be? It's going to be in quadrant 2, because if this is 4 over 4, then 3 over pi has to be up here. So if that's 3/4 pi, what's the distance between 3/4 pi and 4/4 pi? I'm getting all kind of crap for answers. Pi over 4, okay? Okay, so if I'm at 3/4 pi, it's pi over 4 to get to 4/4 pi. So this is a pi over 4 angle in which quadrant? Quadrant 2. So I'm looking for the tangent. What's the definition of tangent? Y over x. So go to pi over 4. What's y over x? Yeah, so square root of 2 over 2 over square root of 2 over 2. I'm in the second quadrant. Tangent is what kind of value? It is negative. So what is this number? Negative 1. Okay. So you can do this without having to convert. You don't really, I mean, it just slows you down to convert that to, you know, if this is 180, what's 180 divided by 4 times 3? You know, that's what the conversion would be. Pi, every time you see a pi, that just means 180. So pi over 4, 180 over 4 is 45. 3 times 45 is 135. That's a lot of work to get through. If you could just do that, do the exercise in radians. Okay, sine of 11/6 pi. So what am I going to do? What have I always done? Where did I start on all of these? Start the angle. What did I always do right here? A 0. What did I always write here? Pi. And then I look at this number 6. So instead of writing that as pi, I'm going to write it as what? 6 over 6. Now when I look at 11 over 6, it doesn't feel really close to 6 over 6, does it? Okay. Let's come back around. So if I went all the way around this circle, 0, pi, what would this be over here? Yeah, it would be 2 pi, but according to Jack, what I was after is, this is 12 over 6 pi. Jake. I thought it was Jack that said it. Well, let's don't argue for the recording's sake. We'll just let that be the mystery for whoever's listening. Okay, guys, if I make one full revolution, that's 2 pi. I'm going to write 2 as 12 over 6. Now, do you get a feel for where 11/6 is going to be? You think it's going to be closer to 12 over 6 or 6 over 6? Quadrant 2. Why quadrant 2? Let's go with quadrant 4. Okay? So here it is, guys. If this is 6 over 6 pi, if I went all the way around, I would be at 12 over 6. So I'm going to have to stop short of that. Okay? So 11/6 pi. What's the distance from 11/6 to 12/6? 5 over 6. These answers, remember all the answers before were either 30, 45, or 60? These answers are going to be pi over 6, pi over 4, pi over 3, pi over 2. So this is pi over 6 in which quadrant? Okay, what's the definition of sine? Y. What's the y value at pi over 6? In the fourth quadrant? Negative. So that answer is negative 1/2. Tangent of 9/4 pi. So I start with 0 here. What do I write over here? So this is pi, and then I look over here and say, I really would rather write it as 4 over 4. Okay? 9/4 doesn't feel real close to 4/4. So if I came back over to 2 pi, that's what number divided by 4? Not 12. Isn't that the same as 8/4 pi? Okay. So 9/4 feels closer to 8/4, right? So that means I would go all the way to 8/4, and what would I have to do to get to 9/4? Go 1/4 more. So that means this angle does this. So this is the angle 9/4 pi. What is this angle right here? Between 8/4 and 9/4? Pi over 4. So this is pi over 4 in which quadrant? Quadrant 1. I'm looking for the tangent. What's the definition of tangent? Not x over y. Y over x. So what's y over x at pi over 4? Yeah. Yep, it is 1. And it's positive in the first quadrant. Okay? Okay? Is this all? I mean, it should start to make sense, but you're going to have to spend time with this to get comfortable with the fractions. Sine of pi over 2. If this is 0 and this is pi, where is pi over 2? Yeah, it's halfway between there, okay? On my unit circle, sine corresponds to what value? Y. Go to pi over 2. What's the y value? Yeah. Y is equal to 1. So y equal 1 at pi over 2. The other way to remember that was where we used to think of that as 90 degrees. Okay, yes. Yep. Okay, a few more and we're done. Tangent. Tangent of pi over 3. So first thing I need to draw the angle. I always write a 0 here. What do I write over here? Yeah, pi, but then I'm going to write 3 over 3 pi. Okay. So where is pi over 3? That's 1/3 pi. Yeah, it's closer to 0. So this is 0, 0 over 3. So pi over 3 would be over here. So this is just the angle pi over 3 in quadrant 1. And you can see it on your unit circle. Pi over 3 is in quadrant 1. So tangent means what? Y over x. So I go to pi over 3 and I look for y over x, and that is what? Yes, square root of 3 over 2 divided by 1/2, which is the square root of 3 over 2 times what? What's the reciprocal of 1/2? 2 over 1, right? So this is just square root of 3. Okay, tangent of 3/2 pi. This is 0. What is this over here? Yeah, so if this is 2 over 2 pi, okay, when I get back around, that's 2 pi. What's halfway between pi and 2 pi? Not 3 pi, halfway between 1 pi and 2 pi. 1.5 pi. What's another word for 1/2? Yeah, 3/2 pi. You should really know that, I'm saying this is 0 pi. You'll get the handle that up at the top, this is pi over 2. This is 3 pi over 2. So tangent of 3 pi over 2. What's the definition of tangent? Yeah, so y over x. Go to 3/2 pi. What's the y value? And the x value? This is what? Yeah, undefined. Okay. And that should be it. Let me look at the homework real quick and see. Yes. So homework, you should get in the habit of filling in the unit circle just like we did on the board here. So 90% of this you already know. What you've got to fill in is in these blue circles, fill in the radian measures. Once you fill that in, then you can start to figure out these values. I don't know why this is like this in your homework, but I mean, if this is bothering you, just do it like that. I don't know why they are like Pac-Man kind of thing, but you can do it Wednesday. So a week from today.